So we're just making a jig to do the boring or the machining on the flanges for the mystery project. It's 25 and 40. We need about 300 to go. Nice chips actually. The Chinese CNC into it. It's not bad actually. Doing well. The material is EN24. The material is EN24. It's very nice to machine. And doesn't need to be super accurate. Because it's taper locked, so, and it's only a jig, so it's not a permanent shaft. It's just for aligning the two flanges together and drill the shaft. Alright, let's finish that off and then we'll see what we're going to do with it. So here we got it. That's going into here, so we can align the two flanges. It's just matching what taper bushes I have. With the remains, it's hot. We at 40.6. We make a plug for this one, a steel plug. That's about 40. The reason why we need a steel plug is because it goes on this alternator and it's gonna be wedged on, and if you do that with aluminium it just floats. So we make a steel plug which goes into the aluminium pulley, and once it's set we just drill a hole in the set screw or pin it, whatever, just to make sure it doesn't float. We make a firm press fit, we make that hot and cool the other part down, so it's gonna be a proper press fit, but just for peace of mind we put one set screw in. I'm down at 40.5 or 40.6. It's pretty hot, I'll leave it alone and finish it off tomorrow. Yeah, it's really nice to machine that stuff. Yeah, it's probably 50 years old. It's EN24 from an old dyno shaft. Really nice material. Tough, but not super hard. Good to machine. The mystery project shafts are from the same material. So that's how it comes together. There's a big side here and the small side here. And then we just need to align it, make sure we're not hitting the same holes. And then we roll that through. We drill it, tap the other side, and that's going to be it. So we lined it up. The holes are here and here, there where the white marks are, and the other holes are here. One here. That's the other hole. We clamped it a little bit so it doesn't move. We got them solid here, but the pulley might move, so we're going to drill the first hole, tap it, put a bolt in, and it's not going to move anymore, and then we go from there. We drill until we hit the other side, and then we just tap an M6. Obviously we need to drill for M6, but we drill a 7.5 until we get the cast iron on the other side, and then we'll see. Eventually I may enlarge the holes for M8. I don't know right now. Let's do M6 for now. Should be okay torque wise, but you never know. So we got the first one done. Now we drill the other side, bolt that down, and then we can easily drill the other two. Not gonna move anywhere. Need longer bolts. They just about stick out. We'll find something. Yeah, so let's do it the same way. It's 7mm, so I got enough clearance, and it worked out quite nice. I drilled it almost down, and then I basically centered in the tip of the hole. It was great. So we're done. We drilled all the holes. I might machine a little bit off so I can put some nuts on the back, just for peace of mind. It's threaded, but it's not very thick. It's only about 5mm. Should be enough for an M6, but it's cast iron, so we might need to machine about 5mm off so we can actually put a nut on here. Right, let's take it apart. We marked it. It's marked here, here and here. Also here and here, so we know how it comes together, just in case it's not absolutely equal. So let's test fit it, and yeah, let's take it apart first and then we'll test fit it and see how it looks all together. So we turned it to size. We're going to part it off with this Chinese parting tool. I parted off the other side already, and it actually works quite nice. I just drilled a hole inside, about 12mm or so, just to make sure when I'm going through it's okay. We obviously go nice and steady here. So I'm trying to part that off. It is actually quite nice. I think we can go a bit faster. It takes a bit to grab, and then maybe you can move it. I need to check the center height. I think it's too high. Anyway, let's part it off and we'll come back. Look at that. We're now through. That was a nice cut actually. That's on standstill here. Alright. So we pressed it in, it's still hot. We put 2 washers underneath so we could remain, or we could guarantee for that recess, because that's the recess we need, so we need to machine that off a little bit. And still hot. We just pushed it in. It's about 0.15mm press fit, so should be fine. It was moving quite hard even if it was hot, and should be fine. We need to machine that to 17, I think it's 17 or 17.5 to fit the shaft of the alternator. And that's about it. Okay, let's cool that down and then put it back on the lathe and machine it. So we got it hooked out and it fits perfectly. There's probably 0.5mm clearance on the outer diameter. That's where it sits, so that's fine. Need to bore the inner diameter to 15, because that's got a bit of a recess on the back. It's like so. It's like so. And that's how it's clamped. Most alternators don't have keyways. They just help with it. We're gonna slam that on with the impact driver, and then we pin the thread so it doesn't come out. Yeah, we need to bore the inner diameter, and then we're done with that. Double check the length, but I think it's okay. We'll figure it out. So here we got it fitted. I didn't tighten it up because I need to put a set screw in it, just to make sure it didn't turn when I was turning it. So it's a firm press fit, but I just want to make sure nothing happens. I'll leave that buzz on just in case I need to remachine something. It doesn't harm. There's enough space for the socket, so, and it doesn't weigh anything, so it doesn't add extra inertia. At least not significant. Looks all good. We need to drill at least one set screw. Probably drill 2 opposite way, so it doesn't affect the balance too much, because that will run at approximately 10,000 RPM at top speed. So a bit of balancing would help eventually. So, and that's how it goes on. It might go a bit, that's just a test fit right now. We got big and small, so this is the big side goes here. A bit difficult to do with one hand. There's our mark. And that's the other side going here. I need 2 hands for that. Let me tighten those screws a little bit and then we'll come back. So, and that's how it comes together approximately. This is going to be a tension roller. Obviously if that's tension, I can't do it right now because everything is moving. We got enough teeth in mesh here. I could use a longer belt and go a bit further. We'll see. It's all. I got a good selection of these belts, so we'll see what we're gonna do. Maybe I put a guide roller here as well. We'll see. We got enough here. We got enough here, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 teeth. That's fine for the power we're gonna transmit here. We'll see. Running out of camera battery again. Once the whole thing is tensioned, it looks better. It's just at the moment I can't put enough force on here. But yeah, I'm happy so far. That goes a bit further this way. We need to machine that and make 2 bearings and a tensioner. This one goes a little bit further in because that shaft can move to the other side a little bit. I'm happy so far. It's what we have, and that was always the plan, using bits we have, and we have that, so we're gonna use it. The reason why it's so close is something goes on the back of this one here. We need that space. We come closer about maybe 10 millimeters. Once this one goes here. Once this one goes here, we can come a little bit further in, use shorter bolts, obviously, and then it should fit. Alright, I just got the message that dinner is ready, so we're gonna stop for today. Enough. Carry on tomorrow or so. Thanks for watching, thanks for subscribing, until next time.